This video will review the Unit 2 written activity, pages 1 through 3. The first law of thermodynamics states that the energy in a system is constant. That energy is not created nor destroyed. Instead, it is transferred and transformed. The second law expands upon this, in that with the transformation of energy, the result is greater disorder, a concept known as entropy. This is because each energy change works in a downhill manner to a lesser state of energy. Question 2. Under standard conditions, the temperature is at 298 Kelvin, 1 atmosphere pressure, a concentration of 1 molar, and a pH of 7.0. Question 3. A reaction with a negative delta G value is spontaneous and likely to release some amount of heat, or is exothermic. And on the other hand, a reaction with a positive delta G is endothermic and requires an input of energy and not spontaneous. Question 4. Endothermic and exothermic reactions are coupled together so that the energy released by an exothermic reaction can be used to power a thermodynamically unfavored endothermic reaction. Question 5. An enzyme's active site is the pocket of the protein that binds to substrates and forms products. Question 6. The activation energy is the energy that is needed to be overcome by a reaction to transition from reactants to products. It can be lowered by using a catalyst such as an enzyme. Note that the delta G does not change for a reaction, even if the activation energy is lowered by the input of an enzyme. Question 7. Enzymes perform under optimal conditions when uninhibited. A competitive inhibitor will slow the rate of a reaction, but does not affect the enzyme's active site, so the enzyme will still turn over product. However, non-competitive inhibitors bind at allosteric sites to cause the shape of the active site to change enough that the turnover rate is significantly reduced. Question 8. In glycolysis, glucose is phosphorylated by ATP to produce glucose 6-phosphate. It is isomerized to fructose 6-phosphate and then phosphorylated again by another molecule of ATP to form fructose 1,6-bisphosphate. It is cleaved into two isomers, DHAP and glyceraldehyde 3-phosphate, G3P or GAP. G3P is dehydrogenated to release NADH and proton to form 1,3-bisphosphoglycerate. ATP is released by substrate-level phosphorylation to form 3-phosphoglycerate. It is mutated to 2-phosphoglycerate, dehydrated to phosphoenolpyruvate, where another molecule of ATP is formed by substrate-level phosphorylation to finally form pyruvate. Note that the second half of this reaction happens twice, so that 2 molecules of pyruvate and 4 ATP are released. Question 9. The intermediate step takes place in the mitochondrial matrix after pyruvate is transported in. Pyruvate is the starting substrate with acetyl-CoA, the final product. Also released are carbon dioxide, NADH, and hydrogen ion. And this reaction also takes place twice, once per pyruvate. Question 10. A sample mitochondrion is shown in the textbook and instructional video.